Hello, let's take a look at some inequalities. Alrighty. So our first inequality we're given in factor form. And if you were in class and watched me, I just did a number line and columns below it. I've got to use a table in Excel for this one. So similar, but all right. So take each of the factors, set them equal to 0, solved, right? And what we want to do is check the intervals in between all of those solutions and see whether that polynomial will be positive or negative. So you can see I've separated my intervals with my inequalities right there. And I'm going to go through the factors one at a time. And I'm just going to go left to right and do them that way. Okay, so the first one is just x cubed. So if you cube a number, it keeps the sign. Any negative number cubed ends up negative. Any positive number cubed ends up positive. So anything to the left of 0, the first 3 intervals are all going to be negative. I don't need to know what the number is. You don't have to worry about that. This is a little fast and quick to do that. And then anything on the right of 0 is going to be positive. Rinse and repeat for the rest of the factors. The next factor is squared. What happens when you square every single real number in existence? It ends up being positive. So all of those intervals are going to have a positive value for that. There we go. All right. And the next one is another cube, but we're separating it by -1. So the first cubed, we were looking at 0. And so now this one we're looking at -1. And anything to the left of -1, which are the first 2 intervals, will remain negative. And then the remaining 4 intervals to the right of -1 will be positive. Like that. Easy peasy. The next one is just a linear multiplicity 1, so it's odd. So again, we're looking at below the 4 or above the 4 is where it will be negative or positive. So below the 4, which is a whole bunch of the first 5 intervals, so only that last interval greater than 4 is going to stay positive. Everything else is negative. Next one, we got x plus 8, another linear multiplicity 1. So we're looking at less than -8, which is the very first interval. It's going to remain negative, and then everything else will be positive. Boom, easy peasy. Now what we want to do is take each of the columns and multiply that through to end up with positive or negative. So now I am just counting the negatives. If you multiply pairs of negative numbers, they end up positive. So if I have an even number of negatives, then my final answer on the bottom row is positive. And if I have an odd number of negatives, then it ends up negative. So the first column, there are 4 negatives. Multiply that out, it ends up positive. The next column, there are 3 negatives, so it ends up negative. Next one, I see a pair of negatives. That's a positive result. And then there's a single negative in the next 2 columns, so they will end up being negative. And the last column is all positive, so it's all positive. And this final row is how I'm going to answer whatever inequality I'm given. Greater than 0 is positive, less than 0 is negative. I pay attention to whether it says equal to or less than, whatever, like that. Now, as an alternative, you already know how to graph polynomials. You learned that a little while in the past. You could do it here if you wanted to. And we're comparing it to 0, which is the x-axis. So you're just looking above or below that line. Option, 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 whichever way you want to do. Now, this could be you do it both ways, a good way to double check. Like that. All right, so let's take that final row of our sign chart, and we're going to do each of the 4 possible inequalities and write the solution out. So the first inequality is a strictly less than. So I'm going to have parentheses, and I just look at those 3 regions, intervals that are negative. So between -8 and -1, skip over 0 to 2, skip the 2, and then 2 to 4. Like that. Super easy. The next one is equal to. So there's going to be a slight difference. It is equal to the value of 2. And I'm not going to write that in my interval notation. So it's basically the same thing, but I don't have any notation for x equals 2, like that. And next one is greater than, so that's going to be the positive ones. Just like before, this one includes the infinities. And then the last one is greater than or equal to. And remember, it can equal x equals 2. So I have to keep that 2 in there, and you can see how I did that as an individual number there with the square brackets. If it's an individual number, you can use the curly brackets as well. That is correct, but I try to just stick with the square. That's the same as the rest of them there. Alrighty, well, I'll see you in the next video, I guess. Bye.